So we're going to end off this first day by talking about heat balance. So we've got a couple of objectives here. Okay, so when it comes to temperature regulation, it's just a matter of what are you doing that's increasing temperature? What are you doing to decrease temperature? And kind of what's the sum of the two? Okay, and there's 5 different ways that we can gain heat or we can lose heat. So one is metabolism, and we can only gain heat from metabolism. And then on the other side, we have evaporation. You can't heat up from evaporation. You can only lose heat from evaporation. Then you've got these 3 others of radiation, conduction, and convection. And those can cause you to gain heat or to lose heat. It just kind of depends on what's going on. All right. And so definitions for these. So metabolism, this is just what you're doing to create ATP and to use that ATP. But when you do it, only a fraction of it's used to actually create energy, or not create energy, only a fraction of that energy is used to do something useful. Okay, so only a fraction of it's used for you to walk or to jump or to run or to talk or whatever it is. Everything else is released as heat. You see the same thing in a car, right? We've talked about what happens to a car when you drive it. You know, like if you touch the hood after you've gone on a long road trip, that hood's going to be really hot because a lot of heat is released while we're trying to, move it forward. So some energy propels the car forward, some of it's just lost as heat. Then we've got radiation. And so radiation is just the transfer of electromagnetic heat waves. Okay. And so you can see this like on the street. If it's really hot outside, if you've ever looked at a street or a fire, you get those kind of wavy lines, like where it just doesn't look quite right. That's due to heat that's being released. Okay. And so things can absorb that heat. Then we've got conduction. So conduction is where you touch something and either you gain heat or you lose heat. So if you touch something that's hot, you're absorbing heat from that hot object, assuming it's hotter than you are. You're absorbing through conduction heat, or your heat is being transferred to you. Okay. Then we've got convection. Okay, so convection is an indirect heat transfer, and this occurs when you're moving or something is moving through a flowing fluid. Okay, and the greater the movement, the greater the heat transfer. Okay, so when we think of fluid, we think of a pool. All right, so when you're swimming, most likely you're experiencing heat loss through convection. But just the fact that you live in a place that has an atmosphere. Air is considered a fluid, so there is convection that goes on there. Now, water has much greater convective properties than air, but it's still convection. And then lastly, we have evaporation. And so this is when we convert a fluid into a gas. Like I said earlier, we lose heat when this occurs, and this is the best way to lose heat. Okay, and I'll say this again later, but it's important to know it's not the act of sweating that cools you off. It's the act of evaporating that sweat. All right, so let's just say that it's a really hot day, and you go for a 30-minute run, and it's 40 degrees Celsius. Remember, normal body temperature is 37. So how do you think metabolism, radiation, conduction, convection, and evaporation will affect body heat? So think about that for just a second. Well, metabolism is going to increase your heat, okay? That's the only thing it can do. And so it's actually going to increase your heat quite a lot because you're exercising, okay? You're going to gain a lot from radiation because it's so hot outside. You're actually going to be absorbing heat from the environment. And then you're going to have a little bit with conduction and convection, okay? Conduction because you will be touching the ground, your feet will and stuff. Your shoes will touch the ground, you're touching your shoes, that kind of thing, okay? But it's relatively small. And then convection will also be relatively small, okay, because we're in air as opposed to swimming. Now, there will be some evaporation as well, and that will help cool you off, but evaporation is also kind of dependent on something, and we're going to get into that in a minute, okay? And so the reason, I guess I need to make this clear here. The reason that we're gaining heat from radiation, conduction, and convection is the fact that the environment is hotter than our body. Okay, generally speaking, we don't get up to 40 degrees Celsius. It's possible, and it does happen, especially if you exercise or work outside when it's really hot for a long time. But generally speaking, our temperature is below that. Heat goes from high temperature to low temperature, so you're going to be gaining heat from the environment if you're exercising when it's above 37 degrees Celsius or above 98 degrees Fahrenheit. And so when that's the case, the only way that you can cool off is through evaporation. Now, evaporation is not evaporation, the effectiveness of evaporation depends on one main thing. How humid is it outside? Okay, so remember we talked last video about those psychrometric charts and how, depending on the temperature, the environment can only hold so much water. Okay, well, if you've got high relative humidity, you're going to sweat a lot, but you're not going to get a whole lot of use out of that sweat because it's not going to evaporate, because the environment can't hold, the atmosphere can't hold more water. However, as relative humidity goes down, evaporation rate goes up. So I'll get a lot more bang for my buck in Phoenix in the summer with my sweat, because it will be able to evaporate, than I will when I'm in Indiana. When I was a kid living in Phoenix, I remember it felt like I never sweat. And even though it was 100, we play when it was 110, 150 degrees outside, 115 just to be clear, not 150. And I remember never sweating. At least that's how it felt. And the reason being is that it was so hot and so dry, it would just evaporate quickly. And so, important to know, sweating does not cool you off. It's the evaporation of sweat. So when you go for a run or you're working out and you wipe that sweat off, you're actually minimizing your heat loss, right? And I understand why you do it, but at the end of the day, you're kind of preventing your body from cooling off as efficiently as it could. So when it comes to temperature regulation, as we've said, our normal core temperature is about 37 degrees Celsius, or about 98.6. Generally speaking, humans can survive in temperatures that range anywhere from 31 to 41 degrees Celsius, although at times we can get above 42 degrees Celsius. And if it's exercise, it's not as big of a deal. If you get sick or something like that, that's when issues can happen. Now, people have survived with core temperatures well above that. I think 46, 47 degrees Celsius is the max. I think it's 118. Someone got up to a core temperature of 118 and survived. Okay, pretty frightening. It took some time, but they were able to survive. All right, but normally, once we get a little bit out of 37 degrees, and notice that we've got a range here. I'm trying to, in this little seesaw here, so 35.6 to 37.8. One person does not have a range of 2 degrees. Okay, everybody has a slightly different set point. And so when you get a couple degrees hotter or cooler, you're going to do things to try and get back into homeostasis. Okay, and so temperature is regulated by your hypothalamus. Like I said, within a pretty small range, couple of tenths of a degree. And the hypothalamus is what causes you, what sends the signals to sweat or shiver, that sort of thing. But in order to do that, it needs help. Now, the hypothalamus has temperature sensors, but there's also sensors throughout your body. So you've got some in your skin and your central nervous system, among others. Okay, and so if temperature is really high, you're going to do things to sweat. If temperature is really low, you're going to do things to shiver. Okay, so a couple of things that happen, and this will lead very nicely into our heat unit, is that when it is hot, the arterioles in our skin dilate. So this causes you to increase blood flow, and just that will allow you to lose heat because you've got those blood vessels that are close to the skin, and that heat can dissipate. At the same time, the sweat glands also are activated, okay? And so we pull water out of the plasma, and then basically we leak water, right? That's what is happening. And so the water that's coming from your sweat was in your bloodstream not too long ago, okay? And the same thing is true of urine, right? All these fluids that we give up, whether it's sweat or urine, they're coming from your bloodstream, okay? So that gives you something to think about. Now, if temperature is low, our skeletal muscles will start to shiver, right, which are those small involuntary contractions. And since they don't provide a lot of useful movement, we release a lot of heat. And then there are some hormones, such as thyroid hormone, that will release, that will increase our metabolic rate, that will help increase our core temperature. And so hopefully now we've kind of set the table so that the last 3 days of the semester we'll be ready to talk about heat, cold, and altitude.